We're going to look at the trig relationships defined for right triangles. The sine of angle A equals the opposite over the hypotenuse. When we say opposite, we mean the leg across from angle A. The cosine of angle A is defined to be the adjacent over the hypotenuse. The adjacent means the leg that is connected to angle A. And then the tangent for angle A is defined to be the side opposite of angle A over the side adjacent or connected to angle A. A shortcut way to help you remember this is to remember the little phrase SOHCAHTOA. So the S stands for sine, the O stands for opposite, the H stands for hypotenuse. In the CA, C stands for cosine, A stands for adjacent, H stands for hypotenuse. And in TOA, T stands for tangent, O stands for opposite, A stands for adjacent. In looking at example 2, we are asked to find the sine of angle A, the cosine of angle A, and the tangent of angle A. So all of these trig functions that we are finding are very specifically related to angle A. So when we want to find the sine of angle A, remember that the relationship for sine is opposite over hypotenuse. The side across from angle A is the 8. The hypotenuse is the 17. So the sine of angle A is 8 over 17. Now let's look at the cosine for angle A. What we are looking for is the leg that is connected to angle A. Here's the leg that is connected to angle A. That's the adjacent. So there's 15 over the hypotenuse is 17. Now for the tangent of angle A, you want to do the opposite, the side across, over the adjacent, the side connected to it, so you get 8 over 15. On example 3, we are asked to find tangent of theta for the figure we are shown. So everything that we are doing for tangent is in relationship to the angle that's over here. Tangent is opposite over adjacent. The opposite currently has no value. We have to figure out what that value is. So in order to do that, we need to do the Pythagorean theorem. So 8 squared plus what we don't know squared has to equal 9 squared. 64 plus x squared has to equal 81. Subtract 64 on both sides, you get x squared equals 17. So x technically is plus or minus the square root of 17, but the side of a triangle has to be positive. So the side that we don't know is the square root of 17. Now that we know the side across from angle theta, we can do the tangent for theta, which is the opposite, the square root of 17, over the adjacent, the leg connected to theta, is the 8. On example 4, we are given a figure and asked to find the sine for angle theta, the cosine for angle theta, and the tangent for angle theta. We are told to use exact values. So that means if we have a square root, we leave it in square root form. Looking at this triangle, we do not know one of the sides. if we are going to find the sine, the cosine, and the tangent, we need to find all three sides. So we are going to set up the Pythagorean theorem, x squared plus 7 squared equals 10 squared. X squared plus 49 equals 100. X squared has to equal 51, so x must be the square root of 51. So the side that we don't know then is the square root of 51. Now the trig functions that we are finding are all in relationship to theta, angle theta. So if we are doing the sine for angle theta, we want the side across from it, the opposite, 7, over the hypotenuse, which is 10. For the cosine, we want the adjacent, the leg connected to angle theta, which is the square root of 51, over the hypotenuse, which is 10. For the tangent, we want the opposite, which was the 7, over the adjacent, which is the square root of 51. You may leave it in that form, or you may rationalize it and write it as 7 square root of 51 over 51. On example 5, the directions say to solve for x in the triangle and to round your answer to the 10th. You will be given a figure, and in these problems, they will give you an angle measure and they will give you 2 of the sides. What you will have to determine is which trig function works for the information that you have. If I look at the angle that I have of the 69 degrees, and I look at the information that I have, I'm looking for x, which is the opposite, and the 19 that I have is the hypotenuse. Well, which function uses opposite and hypotenuse? The sine function. So what we are going to do is set up an equation that says that the sine of 69 equals opposite, which is the x we're looking for, over the hypotenuse, which we are told is 19. Now we need to solve this equation for x. Well, going back to our algebra, in order to solve for x, we would multiply both sides by 19. So x equals 19 times the sine of 69 degrees. Now you're going to put this into your calculator and round your answer to the 10th. If you put that in your calculator, you should get 17.7. This is the measure of a leg, and we don't know if it's inches, centimeters, yards. We have no idea, so we're not going to put a label on it at all. On the second figure in example 5, if we look at what we are given, we have our angle of 21 degrees. We are looking for the side across of it from it, the opposite, and we are given the side attached to it, which is the adjacent. If we have opposite and adjacent, then we need to use the tangent function. So we are going to set up an equation that says that the tangent of 21 degrees equals the opposite x over the adjacent, which is 9. This one will solve just like the last one, so x will equal 9 times the tangent of 21. If you put that in your calculator and round to the 10th, you should get 3.5. Example 6 is a very similar idea to example 5, except this time you are going to find the angle measure instead of a side length. So look at what you are given and what ratio it creates. Our angle x has the information for us of the opposite over the adjacent. So the ratio that we want to set up is tangent. We don't know the angle, so what we're going to do is say the tangent of x equals opposite 13 over the adjacent, which is 20. So this time we have to find out what x equals. On your calculator, there is a key that has this on it, tangent with a -1 exponent. That's called the inverse tangent. This function finds the angle that has the given ratio. So what you are going to have to do on your calculator is do the tangent inverse of 13 over 20, and then this will tell you what the angle measure is. Your tangent inverse key is generally the second function, so you're going to use your second key, and then above the tangent, there's the tangent with the -1 exponent. So you're going to do second, hit the tangent inverse key, and then do 13 divided by 20. When you do that, you should get that x equals, when you round it, 33 degrees. For our second figure in this kind of problem, looking at the angle and the two pieces of information that we are given the side that's connected to it, so we know the adjacent, and the 14 is the hypotenuse. Which function uses adjacent and hypotenuse? That's cosine. So this time we will say the cosine of x equals 11 over 14. Again, you're going to have to use your inverse key, so x will equal the cosine inverse of 11 over 14. When you do that on your calculator and round to the 10th, you should get 38.2 degrees. When you are told to solve a right triangle, what that means is that you need to find all of the missing angles and any missing side lengths. For example 7, we are given a right triangle that we need to solve. Remember, if you have a right triangle, the right angle automatically takes up 90 degrees of the 180 degrees that are the measures of the three angles in a triangle. So that means that the other two angles have to add up to be 90 degrees. If we know that one of the angles is 47, then angle B must be 90 minus 47, which is 43 degrees. Now we need to find side B and side C. When you are solving a right triangle, if at all possible, I recommend that you use your given information. What if we had made a subtraction error finding angle B, and we used that number to find the rest of our sides? Well, now everything's going to be wrong because our first answer was wrong. So I'm going to use everything based off of the 47 degrees that I was given. If I want to find side B, and I look at the information that I am given the side across from the 47. I'm looking for side B, so here is opposite, here is adjacent, and the angle is 47. So that means I need to use tangent. So we would say that the tangent of 47 equals the opposite of 23 over the adjacent which is B that we are looking for. So now we've got to fall back into our algebra and find what side B equals. So the first thing that we are going to do is multiply both sides by B. Now we have B times the tangent of 47 equals 23. Now to get B by itself, we're going to divide both sides by the tangent of 47. So side B has to equal 23 divided by the tangent of 47. Do that on your calculator and round to the 10th, and you should get 21.4. So now we know angle B, we know side B, we still don't know side C. So let's go back and compare what we are given with side C. Here's my angles, 47. I know opposite, and I know C is the hypotenuse. Well, opposite and a hypotenuse is the sine function. So this time, we are going to do the sine of 47 equals the opposite of 23 over the hypotenuse, which is C. This is going to solve just like what we did for tangent. We have to multiply both sides by C. So we have C times the sine of 47 equals 23. We've got to divide by the sine of 47 on both sides. So we get C equals 23 divided by the sine of 47. Doing that on your calculator, you should get 31.4.